Welcome to ScienceCover.com. Let's start with the Do Now task. Pause the video and write down the energy changes that take place when a pendulum swings side to side. In this lesson, we will look at gravitational potential energy and kinetic energy. We shall learn what is the gravitational potential energy, how to calculate the gravitational potential energy with mass and height, calculating the kinetic energy of a moving object, and then applications of the conservation of energy. Lifting a weight off the ground requires energy. This weightlifter is using his chemical energy to raise the height of the weights. When the weight gets higher, it stores the energy as gravitational potential energy. Lowering the weights releases some of this energy, lowering the gravitational potential energy. The gravitational potential energy can be calculated using the equation gravitational potential energy in joules is equal to the mass in kilograms multiplied by the acceleration due to gravity in meters per second squared, and then multiplied by the height of the object in meters. The acceleration due to gravity, or g, is how fast an object accelerates in free fall here on Earth, and it has a constant value of 9.81 meters per second. It will take a different value on different planets, as things will accelerate at different speeds on different planets. We can use the equation triangle to help us rearrange the equation. If we want to find GPE, you cover up the gravitational potential energy, and it leaves us mass times 9.8 times height. If we want to find the mass, then we cover up the mass in the triangle, and this leaves us GPE on the top of the equation divided by 9.8 times height. If we want to find G, so this is usually if we're on a different planet and we wanted to calculate the acceleration due to gravity on that planet, you would cover up G, and you would have to take the gravitational potential energy of an object and divide that by the mass and the height, because GPE is on the top of the triangle and mass and height are on the bottom of the triangle. If we wanted to calculate the height of an object, then you cover up the height in the triangle, and it leaves us gravitational potential energy on the top divided by mass times 9.8. Now pause the video and complete task 1 on the worksheet. Let's check our answers to task 1. Gravitational potential energy is the mass times g times height, where g is equal to 9.81 here on Earth. Complete the equation triangle for GPE, mass, g and height. So GPE on the top of the equation is given, so you had to put mass, gravity and height along the bottom. Let's have a look at an example of how to use the equation. A 500 kilogram rocket flies from the ground 200 meters into the air. What is the gravitational potential energy at this point? Use G as 9.81. So we take our equation triangle and we're being asked for the gravitational potential energy. So cover up the gravitational potential energy and it leaves us mass times 9.8 times height. Now we have an equation, we can replace the words in the equation with the numbers that we've been given. So mass is 500 kilograms. Gravity we know is 9.8, and the height we're given is 200. So GPE equals 500 times 9.81 times 200. This comes to 981,000 joules of energy. Let's have a look at a second example. How high does a ball travel if it is thrown 200 joules of energy and has a mass of 0.2 kilograms? Use G as 9.81 meters per second squared. So this time we're being asked to work out the height. So we cover up height on our equation triangle, and it gives us the GPE divided by the mass times 9.81. Now we can write the equation and replace the words in the equation with the numbers that we've been given. So GPE is 200 joules, the mass is 0.2 kilograms, and gravity is 9.81. This comes to 101.9 joules. Pause the video and complete task 2. Let's check our answers to task 2. Calculate the gravitational potential energy of a 0.1 kilogram apple sat on a 0.75 meter high table. So mass times gravity times height is 0.1 times 9.8 times 0.75, which is 0.735 joules. A 1,000 kilogram tank on top of a 30 meter tall hill. We do mass times gravity times height. So it's 1,000 times 9.8 times 30 is 294,000 joules. C, a 5 kilogram squirrel on the top of a 12 meter tall tree. To get gravitational potential energy is mass times gravity times height. So that's 5 times 9.8 times 12, which is 588.6 joules. Let's have a look how to calculate the kinetic energy or the movement energy of an object. The kinetic energy can be calculated using the equation half times the mass times the velocity squared, where the kinetic energy is in joules, the mass is in kilograms, and the velocities are in meters per second. Let us use an equation triangle to help us rearrange the equation. If you want the kinetic energy, cover up the kinetic energy. It tells you that it's half times the mass times the velocity squared. If we want to work out the mass, cover up the mass, and it tells you that it's the kinetic energy divided by half the velocity squared. If we want to work out the velocity, well, we have velocity squared in the equation, so we can use velocity squared, cover it up. It tells you that it's the kinetic energy divided by half the mass. Now in this last equation, to get the actual velocity, we'd have to work out the square root of the kinetic energy divided by half the mass. Let's look at an example how to use the kinetic energy equation. A 30 kilogram boy runs at 5 meters per second. How much kinetic energy is he moving with? We want the kinetic energy, so cover up the kinetic energy in the equation triangle. And it tells you that it's half times the mass times the velocity squared. If we now replace the words in the equation with the numbers that were given, we get half times 30 kilograms times 5 squared. So that will equal 375 joules of energy. look at a second example. How fast does a 10 kilogram puppy run if it is travelling with 70 joules of kinetic energy? So this time we want to work out the velocity. So if we cover up velocity squared, it tells us to find the kinetic energy and divide it by half the mass. So velocity squared is kinetic energy divided by half times the mass. This means that the kinetic energy is 70 and we divide it by half times 10. So the velocity squared will come to 14. But this is not the velocity, it is the velocity squared. So I need to find the square root of this value. And the square root of 14 is 3.74 meters per second. Now pause the video and complete task 3. Let's check our answers to task 3. The equation used to calculate the kinetic energy is the half times the mass times the velocity squared. Calculate the kinetic energy of a 200 kilogram car moving at 10 meters per second. So we do half times 200 times 10 squared. That gives us 10,000 joules. Part B, a 70 kilogram man walking at 1.5 meters per second. We do half times the mass times the velocity squared. It's half times 70 times 1.5 squared. This gives us 78.75 joules. A 12 kilogram puppy running at 4 meters per second. We do half times the mass times the velocity squared. Half times 12 times 4 squared. This equals 96 joules. Let's have a look at how gravitational potential energy can become kinetic energy. Imagine there's a skydiver who has just left the plane. Let's give him a mass of 70 kilograms. The skydiver has just stepped off the plane, so as of yet has not started to accelerate towards the ground. So we can take his speed, and therefore his kinetic energy, to be 0 joules at this moment. To calculate the gravitational potential energy, we can use the equation mass times gravity times height. Let's give our skydiver the height of 700 meters. The gravitational potential energy of the skydiver is mass times gravity times height. This is 70 times 9.81 times 700, which equals 480,690 joules of energy. As the skydiver falls, his speed increases, so kinetic energy will rise. Meanwhile, his potential energy will decrease as he is decreasing in height. Let's look at the skydiver halfway through the fall. He now has a height of 350 meters. So we can calculate his gravitational potential energy, mass times gravity times height. The mass hasn't changed, it's still 70. G is 9.81, height now is 350, so his gravitational potential energy is 240,345 joules, which is half of what we started with. This makes sense because he is halfway from the starting position to the ground. Due to the conservation of energy, energy cannot be created or destroyed. So the loss of gravitational potential energy has to have changed to something else. It can only have become kinetic energy. So the other 240,345 joules that has been lost from the original 480,690 must have become kinetic energy. So we can write that its kinetic energy is 240,345 joules. So at this point, halfway through the dive, its gravitational potential energy and kinetic energy are the same in value. As the skydiver continues to fall, he will reach the ground. When he reaches the ground, he has no height, so his gravitational potential energy must be 0 joules. This means that all of the gravitational potential energy must have become kinetic energy. So his kinetic energy must now be 480,690 joules. When we look at the original gravitational potential energy and the final kinetic energy, they are the same. This is due to the conservation of energy. All of the lost gravitational potential energy has become kinetic energy. This will be true for all falling objects. Now pause the video and complete task 4 and task 5. Let's check the answers to task 4. A 0.4 kilogram ball is dropped from 7 meters in the air, falls and hits the ground. Calculate the potential energy of the ball at its point of release. So to find the potential energy, we do mass times gravity times height. So it's 0.4 times 9.8 times 7. This is 27.44 joules. What will the kinetic energy of the ball be when it reaches the ground? It will be 27.44 joules. Explain your answer to part B. Energy is conserved, so as the ball falls, the potential energy is converted into kinetic energy. Calculate the velocity that the ball will hit the ground. Well, kinetic energy is half times mass times velocity squared. So if we want to find v squared, we need to do 2 times the kinetic energy divided by the mass. So this is 2 times 27.44 divided by 0.4. Now if we find the square root of this value, then we'll get the velocity. So the square root of 137.2 is 11.71 meters per second. Let's check our answers to task 5. Pendulum is raised from its rest position, position B, and raised 0.3 meters to position A. When it's released, the pendulum swings freely. Describe the energy changes that take place in the pendulum. So when the pendulum is released, it has gravitational potential energy but no kinetic energy. It then begins to move, so it gains kinetic energy but it will lose gravitational potential energy. If the pendulum has a mass of 0.5 kilograms, what will the potential energy be at point A? We need to do mass times gravity times height. So it's 0.5 times 9.8 times 0.3, which is 1.47 joules. What will the kinetic energy of the pendulum be at position B? 1.47 joules. What will the speed of the pendulum be at position B? We need to do the velocity equals the square root of 2 times the kinetic energy divided by the mass. So this is the square root of 5.88, which gives us 2.42 meters per second. What will the speed of the pendulum be at position C? It should be 0 meters per second, as all of the kinetic energy will have been lost and converted into gravitational potential energy.